Hi friends, today we are going to explain you about velocity and acceleration in mechanism. First, introduction. Each link of chain or mechanism is subjected to give definite motion. It means each link of mechanism is subjected to definite displacement, velocity and acceleration at any instant. There are two methods to determine velocity and acceleration of different mechanism. There are two types. First, graphically method and second is analytically method. First, graphically method. Graphically method is subdivided into two types. First, relative velocity and acceleration method and second, clean construction for single slider crank mechanism. And second, analytically method. Analytically method is subdivided into two types. First, vector algebra method and second, complex algebra method. After introduction, we come to next topic, linear motion. Linear motion, it is a motion of body along linear direction. In that, first we explain you linear displacement. When the moment of body is along straight path, it's called as a linear displacement. First, for linear displacement, we draw one diagram here. It is a fixed plane. In that there is a initial position of a body this and the motion of the body along this direction. There is final position of a body. And this is a distance between initial and final position. It's called as a linear displacement. Is denoted by a letter S. And you know friends, the unit of linear displacement is mm or meter. Now come to next topic, linear velocity. The rate of change of linear displacement with respect to time is called as a linear velocity. The formula for linear velocity is v is equal to ds by dt. V means linear velocity and ds means linear displacement, and as well as dt means time, where v is linear velocity, s means displacement, and t means, we know friends, time. Now next, third, linear acceleration. The rate of change of linear velocity with respect to time is called as a linear acceleration. The formula for linear acceleration is that a is equal to dv by dt, where a means acceleration, which we here find, and v is a velocity, and last t is equal to time. After linear motion, we come to next topic, angular motion. Angular motion, it is a motion of body along angular direction. In that, first, angular displacement. When the moment of body is along a circular path, it's called as a angular displacement. For angular displacement, we draw one diagram here. So look here, it is a circle We observe here there is initial position of a body. And there is considered there is a final position of body. The body is displaced move through an angle from theta to initial position to final position. Now the angular displacement means angle between initial position and final position, that represented by formula theta is equal to S upon R. S means displacement and R means radius. Now next topic, angular velocity. The rate of change of angular displacement with respect to time is called as angular velocity. For angular velocity, the formula is omega is equal to d theta upon dt. Omega means angular velocity and theta means angular displacement. And t means time taken for angular displacement. Now next topic is angular acceleration. The rate of change of angular velocity with respect to time is called as angular acceleration. For angular acceleration, the formula is that alpha is equal to d omega upon dt, whereas alpha is equal to angular acceleration and omega means velocity, means angular velocity, and t is equal to time. Now next topic, relation between linear and angular velocity and angular acceleration. In that first topic, relation between linear velocity and angular velocity. For that linear velocity, we know the formula is ds by dt and is equal to, for angular velocity the formula is d or theta upon dt, whereas s is equal to r theta. Now ds upon dt means velocity is equal to r into d theta upon dt, and we know that d theta upon dt is equal to omega. So final formula is that v is equal to, v means linear velocity is equal to r into omega. This is a final relation of linear velocity and angular velocity. Now next topic, relation between linear acceleration and angular acceleration. In that linear acceleration, this formula is dv upon dt is equal to angular acceleration, means formula is d r omega upon dt. And we know that dv upon dt is equal to a, means acceleration. So a is equal to r into d omega upon dt, and we know that d omega upon dt is equal to alpha. So A is equal to R into alpha. This is a final equation for relation between linear acceleration and angular. Now next, acceleration analysis. In that, first, accelerated acceleration. It is defined as the total acceleration of a particle with respect to a fixed point. And need of acceleration analysis. Acceleration analysis plays a significant role in the development of machine and mechanism. Force is produced the mass and acceleration. Therefore, if the value of acceleration is known as force on the link can be calculated. Next, acceleration analysis forms the basis of stress analysis of mechanism. We will draw how to acceleration calculated. We have the diagram for acceleration analysis. In this diagram, there is a fixed point O. On the fixed point ON, rotating link is connected. In this, we have to find acceleration of body moving along a circular path. Other link is moving along the circular path connected to tangential on the circular path. The acceleration of this link is called tangential acceleration. On the acceleration is normal rotating link. Then we see the acceleration diagram which is drawn on right side. In this, first we have drawn the rotating link which has angular velocity and angular acceleration, and second link which has tangential acceleration which is denoted as a t. Absolute acceleration of point A which represented fixed point O is given as AO is equal to AR plus AT, and there is two component, first radial component and second tangential component. Radial component of acceleration which is perpendicular to velocity of particle at given inside, and tangential acceleration component of acceleration which is parallel to the velocity of particle at given instant. Next, relative acceleration. Consider 2 points A and B on the link given in the figure. The acceleration of point A is known in direction and magnitude as given in figure. At the some point, point B is moving along the path as shown in given figure. Acceleration of point B is not known. Acceleration of point B is determined by drawing the acceleration diagram of the following way. First, draw vector AO to represent the absolute acceleration at point A, and acceleration of point B with respect to A as following two components. First, radial component of acceleration of B with respect to A and acting along AB, and second, tangential component of acceleration of B with represent A and acting perpendicular to AB. For this, total relative acceleration of point B with respect to point the given vector sum of about two components A and 2. It is represented by line joining point B and A.